Welcome to In the Workshop. This is my workshop, not the Steam workshop, and it's called Good Things on My Workbench in April 2018. So what's this one all about? Well, it's just about a random collection of things on my workbench. Most of the parts you see here are from Blackgates Engineering, and I'd like to take this opportunity to thank the viewers who arranged the gift vouchers. You know who you are, and I thank you very much indeed. One item frequently on my shopping list are paintbrushes. And I frequently add these to my collection of paintbrushes because you can never have too many good quality paintbrushes. When I look at the work of Leonardo da Vinci and Michelangelo, I would think they went through a lot of these paintbrushes when painting things like the Mona Lisa and the Sistine Chapel. This is a stick of cast gunmetal, and I'm going to use this, or part of it, to make a new turret for the Chinese 14XX locomotive that I'm working on. The original steam turret was horrible, so the best place for that is out of the way. For the video, I cleaned up the cast stick of gunmetal on the belt sander, not that it was particularly bad to start with. And here's another piece of phosphor bronze that I'm going to thread so I can screw the turret into the boiler. I'm not going to make the turret in this episode, this is just about nice things on my workbench. And when I do make this turret for the 14XX locomotive, it will be part of that series. What I am going to do in this episode though is just mock up the layout so you can see roughly how it's going to go together. The first job will be to machine this block down to a reasonable size, but then I'm not going to just drill and tap it and fit the valves into the block like I normally would do. I'm going to fit bushes to it. This will just make it look a little bit better, as well as giving a greater depth of thread to screw the valves into. I know it's a bit shameful, but I bought these bushes from Blackgates Engineering. I could have made them, it's a 10-minute job, but I thought no, just for a change, I'll buy some ready-made ones off the shelf just to save some time. Later on in this episode, I'm going to show you an idea that I've had to save a lot of time. So here's the approximate layout from left to right: the pressure gauge, followed by 2 injector steam valves, a whistle valve and a blower valve. The left-hand side of the picture, underneath the pressure gauge, is a standard clack valve, but if I use this, I will of course take the ball out of it. The pressure gauge needs a thing called a siphon. It doesn't have to be a loop like this, but it needs to be a length of pipe in which some steam will initially condense, then you have a water barrier between the steam and the pressure gauge. The internal bellows of the pressure gauge are soft soldered, and it could be damaged if it was mounted directly to the turret itself. I bought these 2 items the other week when I went up to Blackgates Engineering. They are injector water valves, and I'll be using these on the 14XX to regulate the water flow from the tank to the injectors. This is the original water gauge fitting off the 14XX, and as you can see, it's okay, nothing wrong here, except it's too big. If you compare it with the one I'm going to fit, as you can see, it's a good bit smaller. The original lower water gauge fitting would be more suited to a 7¼ inch gauge locomotive. The good thing is the original fitting measures ½ inch from the centre line of the fitting to where the bottom nut starts, and the one I'm going to fit measures just over ½ inch from the centre line of the fitting to the top of the nut. This measurement is critical because inside the boiler of this 14XX the firebox crown is quite high up, so it is absolutely essential that the level of water in the boiler never drops below the top of this bottom nut. I was a little bit concerned that all of the threads on this boiler were going to be metric, but it appears that this thread is 9/16 by 26. But really I think yes, the threads on this boiler are metric, but they're a very fine metric, and my Imperial ME type threads seem to fit the boiler bushes fine. I bought this 7/16 by 26 die because I need to make some blanking plugs to plug up all the holes in the boiler for the hydraulic test, and I will machine the safety valve plug out of this piece of brass hexagon. Here is my really good, really useful, time-saving tip. I bought a lot of these. They're not very expensive, available from Blackgates, and what I'm going to do is put dies in every one of them. All the proper engineers and experts out there, please don't write in just yet, at least watch the video to the end. I currently have 3 tailstock die holders. The first tailstock die holder is very old indeed, probably an apprentice piece from many years ago, and the other 2 die holders that I have are Chinese ones. And these are okay, but the cost of them is around £30. These die holders, like the one I'm working with on screen at the moment, are really nicely made and they're a lot cheaper than a tailstock die holder. So what's the plan? There's nothing special and nothing new under the sun about fitting a die into a commercial, hand-operated die stock. But if you use a die stock like this in the lathe, it may wander about a bit, and maybe your thread won't be quite as true as you think it should be. So here are some of my newly purchased die holders. And here's one of my tailstock die holders, and as you can see, the part I'm holding in my left hand fits into the tailstock, and it's a number 2 Morse taper, but it has a parallel shank that fits into the die holder itself. And as you start the threading process, this parallel shank that's in the tailstock holds the die holder perfectly concentrically with the work that you're currently cutting the thread on. On the other hand, these small die holders that I've just bought, that I'm currently fitting dies into, don't do that. So all I have to do is simply make a sleeve that fits over the shaft that protrudes from the tailstock, and on the end of this component I will machine a register that fits snugly into the back of these die holders. And that will effectively convert these preloaded handheld die holders into tailstock die holders. And why do this, I can hear you ask? I already have tailstock die holders. Yes, but these are preloaded. I really do find it time consuming, changing dies all the time in my tailstock die holders, and my big toe on my right foot really hurts. And it's never been the same since one of these quite heavy tailstock die holders fell on it. Back to the job in hand, I found a piece of wood in the workshop, and I drilled suitable holes in the piece of wood to support the die holders. Now I'm painting it with grey primer. Why am I painting it with grey primer? Why aren't I painting it green? 2 reasons really. One is it's not a steam engine, and the grey primer will allow me to write on it in black felt tip pen, so I can tell at a glance which size die is fitted into which die holder. This will really speed up the process for me, and there's less risk of injuring my feet. The last part of this video is interesting. This is all stuff from China. Now I know a lot of people go on about how bad things are from China, but believe me, this is not bad at all. It is excellent. If you're a beginner, you may be a bit confused. What is it? It's a pipe bender, and to prove that, I'm going to bend a piece of pipe. It's a very small pipe bender. It's nothing new. The design has been out for many years, and you can buy these in various sizes, but not as small as this one. This is really small. By comparison, this is the one I would normally use for bending pipes. And once I've bent the pipe using this pipe bender, it's then possible to see the difference in the radius. See how much tighter the smaller bend is? This, by the way, is 5/32 of an inch diameter pipe, or 4mm, and this pipe bender will also bend 1/8 of an inch diameter pipe, and possibly down to 3/32 of an inch pipe. This is a top quality product, and it's beautifully made. All these items were sent to me from China from a viewer in Alaska, so thanks Jerry, I do appreciate it. These high quality items are all from a company in China called Microcosm, and they also sell on eBay. This is a gas valve, but not just any gas valve. You connect steam from the boiler into the steam unit in the centre of the fitting, the one surrounded by stainless steel bolts, and the pressure of the steam then controls the gas output. I assume that with a bit of adjustment, when the boiler blows off, you can turn the gas down automatically. This is not much good for my kind of application, but very good on a small steamboat, I would think. This next item is a standard gas tank valve, and I really like this a lot. And I'll tell you why I like this a lot, because it's not as stupidly tall as most of the gas valves out there on the market. So it's far easier to fit this gas tank inside such a thing as a model boat, where space is often limited. And usually gas tanks don't fit because the valves are too tall. And what's this? This is very small, as you can see by the size of my hand. Although my not so delicate piano playing fingers are making it look a bit smaller than it is. It is of course a small water pump, and it's complete with an eccentric with an oil cup and a mounting bracket. The only thing wrong with this pump is it's a little bit small. The shaft diameter I think is 4mm. I know it won't fit on a Cheddar puffing engine that I have, because it would have been good for that. Again, it's a very nicely made item. This next gadget is really clever. It's a glass displacement lubricator. It looks a little bit like a piece of medical equipment. Once again, the machining is to die for, all computer machined, a very beautiful thing. I'll test this and see if it works. You even get some spare O-rings in the package. Saving the best till last, look at this. This is a flyball governor. Once again, it's really well made, really well machined. I can't fault it at all. I love the design. When you connect this to a steam engine's crankshaft using a pulley, as the engine's speed increases, it spins the governor faster, and centrifugal force causes the balls to spin outwards, and this in turn moves the lever that operates the valve as I'm just showing here. This reduces the amount of steam fed to the engine, therefore keeps its speed more or less constant. And this small steam valve actually works. It regulates the pressure through it. I think I'll put this back in a bag until I find an application to use it on. And that concludes this episode, so thanks for watching and I hope you found it useful.